Hey everyone, geophysicist Stefan Burns here. There have been some notable plasma outbursts from the sun over the past 24 hours, 3 back to back from the limbs of the sun. They're not exactly Earth directed, but they're showing that solar activity is increasing pretty quickly as we approach some pretty critical planetary geometry around June 21st, and in fact going all the way to the end of the month. But before we get into that, let's just examine and check out these spectacular lava fountains that are currently ongoing at Kilauea Volcano. Episode 25 has started. That was yesterday. This is right around noon to 2 p.m. local time for Hawaii. These huge, super tall lava fountains, about 1,000 feet tall. That's 305 meters. And so these are some of the biggest eruptions that have occurred with this most recent set of eruptions at Kilauea Volcano. And this is just showing that there is a tremendous amount of pressure being generated by that hot spot in this mafic magma, which is down below, which is, iron rich and low viscosity, is able to shoot up and basically blast off to these incredible heights. And I find it very interesting that we have these lava fountains at Kilauea Volcano right as we also have these plasma fountains take on a very similar shape on the sun. This is our latest imagery. This is occurring right now as I'm filming this. A pretty significant ejection of plasma there from the western limb solar coordinate system. But look how just similar it is in terms of the shape and the size. I think it's very interesting how coherent that structure is to what's been happening with Kilauea Volcano with episode 25. But if we look at our sun a little bit further back, we'll see 2 big coronal mass ejections launch out over the past 24 hours. First one here from the limb, check this out. This is pretty high velocity. And then also this plasma filament up there destabilized and launched out. So a double plasma filament sequence here. And keep in mind, these plasma filaments are energy highways on the outside of the sun, so the circumference. And so you have a lot of plasma flowing through them. They host really strong electric currents. They cause a differentiation of elements, these different ions, whether it's like hydrogen or helium or heavier elements, they separate out in these magnetic ropes. And so a plasma filament breaking like this is not just a release of plasma out into space, it's also then changing dynamics with the solar corona and more. And we have a very large coronal hole that's currently on the Earth-facing side of the sun, expected to go geoeffective around June 14th, according to NOAA's space weather forecasters, and they are forecasting a G2 geomagnetic storm. So that is rapidly approaching. We'll discuss all that and much more in today's video. Here we have our latest 211 angstrom imagery of the sun showing us this very significant and very large coronal hole. This in fact is the 10th rotation of this coronal hole. So it's been a very long-lived structure going all the way back to October. It was very tiny in October, but it has been growing since then. Rotation number 7, 8, and 9 were very large. It's looking like rotation 10 is similar in its size and overall dynamics. It's located in about the same part of the sun in the southern hemisphere, but we do have this section of the coronal hole here stretching up to the equator, and then there's also this other trans-equatorial part right there, and this part seems to be growing. So this is getting close to the geoeffective position. That's right around this zone there. And so when that happens, the high-speed stream of ions being emitted from this open magnetic field on the sun is going to interact with the Earth. And this is a positive polarity coronal hole. So it's not the most likely to give us a super strong solar storm impact, or rather supercharged solar wind impact, but we have seen G2 storming from this coronal hole before, and that is what the official forecast is from NOAA at this moment in time. So this is a big coronal hole, an area on the outermost part of the sun, the solar corona, the atmosphere, that's basically deficient in plasma. So there's very low plasma density. Also the temperature as a result is lower, so it shows up dark, but this is not an actual hole in the sun. But the interesting thing about coronal holes is that they have this unique connection to plasma filaments. And we've seen before how when a plasma filament destabilizes, it can actually then reform, and that vacuums up some of the solar corona, creating a coronal hole. And so we just had this big plasma filament here blast off from the eastern limb. I mean, check this out. This is like a very significant launch of plasma out into space. Does not appear to be Earth directed, though there is a little bit of like a kind of like a whiplash effect to it, but doesn't appear to be Earth directed, mostly going north of the ecliptic plane. But we do see some changes to this part of the coronal hole here right after that occurs. And so it looks like this is starting to grow actively, and then this I don't think really necessarily helped in terms of closing this coronal hole up. You see a little bit of an expansion there at the end. So minor changes, but still we're seeing this activity with these plasma filaments blasting off. We had that eruption here as well. That is from a region departing, has not raised the proton flux, so it does not seem that that is going to trigger any sort of radiation storm. You usually need like a solar flare, an explosion on the sun to do that, not just the release of a plasma filament. But regardless, solar activity is clearly going up, and soon we'll have that critical planetary geometry. Now, before we get to that, let's examine our most recent coronagraph imagery so we can see these two big plasma filaments that have launched out into space where they're propagating. Because if you were to have something launched directly towards us like that with a full halo coronal mass ejection, then we know it's headed our way. But as we see, this is the second one right there. That is clearly going to the north and to the east. And this first one, pretty high velocity, you'll notice, is going there to the west solar coordinate system. So it does not look like these are going to be interacting with the Earth at this moment in time or in the days ahead. We're not getting a relativistic flux enhancement from this one, and this one doesn't have really any sort of significant push in this region there, which would show some sort of Earth-directed component. So it looks like these are both going in different locations, not towards Earth, but it's definitely showing that the dynamics on the sun as it relates to the magnetic fields and the electric fields is becoming more unstable, you could say. And that's kind of one of the prerequisites for significant solar activity, like big solar flares. And so I expect there to be some significant solar flares during this critical planetary geometry period, which really comes into effect around June 20th, 21st, but really kind of extends all the way out to the end of June. And so that's really the time range I'm looking for as it relates to high M-class flares, potentially even X-class flares, but we'll need the sunspots to do that. So let's check out our sunspot intensity grams. Here we have our latest intensity gram data showing sunspots on the Earth-facing side of the sun, and you'll see that there aren't that many of them, especially compared to some of the months prior, like August 2024, when there was a tremendous amount of sunspots on the Earth-facing side of the sun. Right now, the daily count is just under 150, but that is a pretty significant bump over where we have been for the past 30 days. And if we look at the far side of the sun, thanks to solar orbiter, which is exactly 180 degrees opposite the Earth right now, we don't see that many sunspots on the far side. So the majority of sunspots are on the Earth-facing side of the sun. This group right there rotating towards the western limb, soon they're going to be off the disk, but we do have new sunspot groups rotating in. There seems to be a little bit of growth with this one in particular, but it's nothing to write home about yet. None of these are really super crazy. So as it relates to critical planetary geometry, perhaps triggering significant solar activity and space weather, that would generally require, a big sunspot group. And so right now we don't really have them there. So it's perhaps through the alignment of these celestial bodies, right, the different planets, that you get this stronger gravitational vector, which causes a disturbance on the sun, which then alters the electromagnetic field. Because you have the gravitational field, which is also the gravitational force, right, the fundamental force of gravity. Then you have the electric field, magnetic field, and therefore the electromagnetic force, a fundamental force of the universe. And gravity is much weaker than electromagnetism, but it's not completely insignificant. It still has an effect, especially with plasma, which still has mass. It's highly charged, so it's much more under the control of electromagnetic forces, but it still has mass. So if you have changes in gravitational alignments in the field that perhaps can trigger disturbances on the sun, that could then perhaps generate these sunspots. And that's kind of one of the ideas as to how planetary geometry could then trigger space weather, because maybe it is what's generating some of these sunspot groups to form. It's enough of a trigger to then cause the rest of the process to unfold. Like a small domino pushing over eventually a very large domino, the butterfly effect. So that seems to be the case. We'll just have to wait and see as it relates to the critical planetary geometry that is active starting around probably June 19th, June 20th, but really locks in June 21st and then going all the way to the end of the month. because right now we don't really have the sunspots that would give us that sort of solar activity. But if we get a big new push of flux out from the sun, perhaps through these gravitational dynamics and the interaction of gravity with electromagnetism, then that could happen very quickly. We've seen sunspot groups on the sun form really fast before. So the sun is not looking like it did back in August of 2024 when we had our monthly sunspot count high for solar cycle 25 maximum, but it is more active than it has been, and that is letting us have a little bit of a clue that there may be some significant space weather headed our way. In the last video, we examined the planetary geometry for the rest of June, but let's just quickly go through it one more time. Here we see the Earth, we see Jupiter, Venus, Mercury, Mars. This is the first 5 astronomical units. If we zoom out, we see the other gas giants, Saturn, Uranus, Neptune. These distances are all to scale. The angles between the planets are scale. It's just the size of the planets are not to scale in this application called Solar System Scope. Today, June 12th, we see the positions. We see Jupiter there, soon to be on the other side of the sun in alignment with the Earth, because if we zoom forward, Earth has a higher orbital velocity. It will then go in and form this alignment there. This is a Jupiter-Sun conjunction, and that is right around the 25th of June. But if we zoom out a little bit and actually go back to the 21st, we see that is around the time that Mercury and Mars line up. And you'll also see this alignment starting to form there with Neptune, Saturn, Ceres, the dwarf planet in the asteroid belt, makes up 1/3 the mass of the asteroid belt, about 1,000 kilometers across, Venus. And then if we zoom forward, we see that they form an alignment there that the sun is not really participating in. It's slightly off from the center of the sun, but that is a very significant alignment at the very end of June, early July. Really right about there, June 30th is when that's probably the most precise. So we have on the 21st of June, we have this Mercury-Sun conjunction from the perspective of Mars, and then this really clicks in right there, and then we have that alignment carry us through the end of June. This is the critical planetary geometry. It's active. You'll notice that this aligned gravitational vector, gravity likes to work in lines, straight lines. That is right, basically cutting through the Earth-facing side of the sun right there. And specifically kind of like these areas there that are close to Earth center direct, but a little bit closer to the limbs. So it'll be really interesting to see if this alters the sunspots on the Earth-facing side of the sun, and then with Jupiter there in the back, perhaps working its magic, because it's the second biggest gravitational influence in the solar system, definitely the biggest plasma body in the solar system other than the sun. And so this alignment right there, I think, is very significant, but we'll just have to wait and see. And looking at our real-time solar wind data for the past 3 days, we see that we have had a bit of an increase in geomagnetic volatility here on Earth. We can look at our KP index, a measure of the changes in Earth's magnetic field strength across time. This is a global index, so these are the field swings being measured at the surface. And when you have very low values, so like 0, 1, or 2, that's a very quiet magnetic field, not much perturbations or vibrations. But we see that go up. Here we have a KP index value of 5, which is a G1 storm. So we had a G1 storm, and then just under that, a G1 minus for a 4.67 KP value. There's about 6 hours of enhanced geomagnetic volatility just in the past 24 hours. Because of the solar wind, the magnetic field strengthened to about double. Normal strength is 5 nanotesla. It went up to about 10 at times, even 11 as we see there. And the red line is showing the southward Z component of the magnetic field. When that goes negative, that connects nicely to Earth's northward field, which is positive. And so we see that we had these buckets there allowing for that nice connection and therefore increased geomagnetic activity across the globe. Our plasma density didn't change much, our velocity didn't change much, nor did the temperature. It's really more magnetic field change for the solar wind that triggered this increased geomagnetic volatility, but it wasn't that significant. But it is interesting that we had this increase in geomagnetic volatility, and then right afterwards we did start to see some interesting earthquake activity. Let's check it out. Here we have our USGS latest earthquakes map showing all earthquakes magnitude 4.5 and greater for the past 7 days. And so that G1 geomagnetic storm lasted from about midnight to 6 a.m. Universal Time today, June 12th, 2025. And if we zoom in here on the most significant activity that we've had in the past 24 hours, it comes from the Pacific Antarctic Ridge. And so we see 4 earthquakes there, and this 5.7 being the largest notice the time, that is at 4:58 Universal Time today. And they're all clustered right around that time zone. It was a little bit of a seismic burst there. These magnitudes aren't necessarily abnormal as it relates to a spreading center. They can go up to magnitude 6, even like magnitude 6.2. If you see something beyond that, that's a little unusual. But those are the most significant earthquakes we've had over the past 24 hours. Though there's also been some earthquake activity for the past 48 hours. It's been sort of notable. For example, this 5.9 in Taiwan. And there was also some other magnitude 5 activity in Japan and in the Philippines right around the same time. Is an interesting sequence of Philippines, Japan, then Taiwan. There's a lot of interest right now and eyes on this part of the globe due to this like July 5th prediction. So just interesting to point out. But we haven't had any magnitude 6 earthquakes since that 6.3 in Colombia. So it's just been magnitude 5s, that 5.9 for Taiwan being the strongest. No magnitude 6s yet. It's only been a few days now. I mean, this is the 8th of June, and now it's the 12th. So not even a week. But in general, the earthquake activity hasn't been exceptional with like high magnitude 6s or 7s, but that may change with that upcoming coronal hole high-speed stream, because as we know, as we've been discussing on the channel for a long time, large coronal holes seem to be connected to the highest of magnitude earthquakes across a very large data time span. So every time that there's a very high magnitude earthquake that we look at the sun, across our limited record of solar data going back to like the 70s, there's usually a big coronal hole right in that geoeffective position. Not a small one, but a big one. So we have that new coronal hole that will soon be going geoeffective. That's actually not new. It's the 10th rotation. It's also the continuous loading of this energy into the earth that seems to trigger these big earthquakes, because it just progressively loads the fault with more and more energy until it finally ruptures. So we are looking at the 10th rotation of that coronal hole to perhaps pick up global earthquake activity, but we'll just have to wait and see if that does pan out. And the last thing I'd like to point out are a few unusual signals that we've picked up in the Schumann resonances. Here we're looking at a vertical electric field spectrogram as collected by the Space Observing System in Tomsk, Russia. They seem to have the best Schumann resonance data, the highest resolution, and in general their location on the globe seems to pick up more of these abnormal signals than some of the other public data stations, but there's very few of them. One of the goals of my work is to build a public observatory network, not only in the USA, but across the globe. We hope to get there with time, but we see a very unusual kind of long duration energy change here. Notice with mode 5, first off, the fact that it actually shows up at a fairly high amplitude. If I scroll over, you'll see our power legend here. And so blue and indigo are low power. You go up to like white, red, orange, that's higher power. And green is kind of like moderate. So typically mode 5 shows up pretty weak because they apply a filter to 32 hertz and above that just drops the gain by about 15 decibels or so. But here we see it actually shows up, and we see this like curved pattern there going from about 5 a.m. local time, UTC plus 7, all the way to about 2200, again, UTC plus 7. And we see a bit of a reflection pattern here with mode 3, which is around 20 hertz. So this is the 20 hertz zone, as you see there. And then we see this is around that 33 hertz zone right there. So this is a very unusual pattern. But we see some other things too that are just kind of odd. So they're worth mentioning. We see this right there. I mean, I can try to zoom in on this. This is very bizarre. I don't really know what the heck this is, but you don't see things like that often. That's weird. It's worth pointing out. I don't know what it is. It's a very high frequency as it relates to the normal Schumann resonances. That's right near 40 hertz. That's like in the mode 6 range. Would that be 39 hertz? So that's kind of bizarre. And then we also do see some activations across the other modes. So if you go back here, we see mode 2 had a bit of an activation, 14 hertz, right before this unusual signature there. And if you're wondering what the heck this big blob is, which is really high power, according to that power legend, this is a local atmospheric effect because they had rain and thunder and lightning over Tomsk, Russia at this moment in time. So this is a very classic signature for like a thunderstorm passing overhead. And you can even see that spike there, right there. That would indicate that that was right when there was maybe lightning happening really close to the observation station. So that's a very classic signature for a thunderstorm. So we're looking at some of these other things which are not classic signatures for a thunderstorm. But there's two more. We see this very, very brief but high intensity amplitude increase there across the spectrum, which is kind of bizarre. And we also see one here. And what's interesting about this one right there is that it doesn't bleed up to the lower frequencies or the higher frequencies. It's centered right in that range that's associated with pre-earthquake signals. So that's going from about 15 hertz to 35 hertz. So it's centered right in there. And it's a pretty significant amplitude bump for mode 4, which is around 25, 26 hertz, which is really the mode of the Schumann resonances that seems to pick up these pre-earthquake signals. So that's a little bizarre, but it is a very, very, very brief increase in that power. And we can't say exactly what that's connected to. But in general, the weirdest thing on here is certainly this pattern, I would say, but there are other things as well. This little dot pattern there is kind of bizarre. And we even get like an unusual energy signal there that almost looks like a whistler, which is when you get a lightning strike, it can create basically a whole bunch of particle flux up to the radiation belt. So it can create this low frequency signature, but it's not exactly that. So just in general, things are just looking a little weird with our background naturally resonant energy fields, the Schumann resonances, but nothing super, super definitive or obvious like, hey, we probably have something happening soon, but definitely things are just looking a little abnormal as it relates to the Schumann resonances. That's it for this Space Weather and Earth Geophysics report. Thank you all so much for watching. Again, I've been your host, Stefan Burns. Please smash that like button to help the channel grow and subscribe if you haven't done so already. We cover on this channel geologic events and significant geophysical energies. We also examine solar activity and space weather because it has a significant influence over the energetics of our planet. We also examine planetary resonances, cosmic forces, and more. I combine all that together holistically, present videos almost daily. If you like the sound of that, then please subscribe. We're on the road to 500,000 subscribers right now. The channel's been going crazy recently, so thank you all so much. Wishing all of you well, and have a great day.